Objects that violate known physics are not just technological marvels. They are ontological claims. The phenomenon breaks physics. We said this at the close of last video. Now we must examine what that statement actually means. Not loosely, not metaphorically, but precisely. If objects are doing what credible witnesses and instruments report, then one of two things is true. Either our understanding of physics is radically incomplete, or our understanding of what counts as credible evidence is radically mistaken. Neither option is comfortable, but comfort, as we've established, is not the currency we're trading in. Let's look at what the phenomenon actually does. In 2017, when the Advanced Aerospace Threat Identification Program, ATIP, emerged from the shadows, its former director, Luis Elizondo, introduced a framework for describing UAP capabilities. He called them the Five Observables, characteristics that appeared consistently across high-quality cases and that defied conventional explanation. They are: 1. Instantaneous acceleration. Objects that move from standstill to extreme velocity or that change direction abruptly at hypersonic speeds without any visible transition period. No ramp up, no curve. Simply here, then there. Number 2. Hypersonic velocity. Speeds vastly exceeding what any known human technology can achieve within the atmosphere. Not just faster than our fastest jets, but faster in ways that should tear any physical structure apart from aerodynamic stress. 3rd, transmedium travel. Movement between different physical media, air to water, water to air, or space, without any apparent change in performance characteristics. No splashes, no hesitation, no accommodation to the radically different physics of liquid versus gas. 4th, low observability. Objects that appear on some sensors but not on others, or that seem to resist detection in ways that go beyond stealth technology. Not invisible exactly. Something stranger. Selectively visible. 5th and last, no visible propulsion. No exhaust, no wings, no rotors, no jets. Nothing to account for the energy output that the observed motion implies. Objects that move without appearing to move themselves. These 5 observables are not individual anomalies. They are a package. They appear together, case after case, decade after decade. If we are dealing with misperception or hoax, the misperceptions and hoaxes are remarkably consistent in their impossibility. Let's examine each. Let's start with instantaneous acceleration. Acceleration is not mysterious. We understand it well. When you press the gas pedal, the engine produces force. The force accelerates the car. The car gains velocity over time. The relationship is expressed in Newton's second law. Force equals mass times acceleration. For any object with mass, acceleration requires force sustained over time. The more mass, the more force required. The faster you want to accelerate, the more force per unit time you need to apply. But there are limits. Structural limits of the vehicle, limits of fuel and engine power. Limits imposed by the human body's tolerance for g-forces. A fighter pilot performing aggressive maneuvers experiences perhaps 9 Gs. 9 times the force of gravity pressing them into their seat. This is at the edge of what the human body can tolerate without losing consciousness or suffering injury. The planes themselves are engineered to handle somewhat more, with significant safety margins. The phenomenon, though, demonstrates accelerations that would instantly kill any biological pilot and likely destroy any known material. Estimates from radar data and visual analysis suggest accelerations of hundreds of Gs. Some calculations based on apparent instantaneous direction changes at high velocity suggest thousands. There's no black project explanation for this. You cannot secretly solve the structural materials problem, the pilot survivability problem, and the energy requirement problem simultaneously, without the solution also revolutionizing every other field that depends on material science, biology, and power generation. If any government had solved these problems, the world would look different in 1,000 ways. It doesn't. And we don't behave like a civilization that has cracked propellantless high-G propulsion. We still burn kerosene to get things into orbit. Hypersonic velocity compounds the problem. An object traveling through the atmosphere at hypersonic speeds, Mach 5 and above, encounters extreme resistance. Air molecules at those velocities behave less like gas and more like a barrier. The friction generates enormous heat, and the pressure can crush structures. Even our most advanced hypersonic missiles, tested in carefully controlled conditions, frequently fail due to materials limitations. The phenomenon operates at hypersonic speeds without apparent heating, without visible shock waves, without sonic booms. Commander David Fravor, the Navy pilot whose encounter with the Tic Tac off the coast of San Diego in 2004 became one of the canonical UAP cases, reported watching the object accelerate from a hover to beyond the horizon in less than a second. Radar operators estimated its speed at over 24,000 miles per hour. At that velocity, in atmosphere, any known object would become a fireball. The Tic Tac did not. Transmedium travel adds another layer. Water is roughly 800 times denser than air. The physics of moving through water versus air are completely different. Submarines are shaped differently from aircraft for exactly this reason. No single design is optimized for both. And yet, witnesses report objects entering and exiting the ocean without splash, without visible adjustment in velocity or behavior. The USS Omaha footage, released in 2021, appears to show a spherical object entering the water. Search attempts found nothing. The object either traveled away underwater at speeds no known submersible can match, or it simply ceased to be where it entered. What moves through air and water with equal ease? What disregards the radical differences in medium? Nothing we've built, and nothing we know how to build. Low observability is perhaps the easiest to dismiss as advanced stealth technology. Except that the phenomenon's version of stealth doesn't behave like ours. Our stealth aircraft work by minimizing radar cross-section through geometry and materials. They are not invisible. They are harder to detect. They still show up on infrared. They still make noise. They still interact with the environment. The phenomenon shows up inconsistently. Radar operators in the Nimitz encounter tracked objects on the Spy-1 radar system, one of the most sophisticated on Earth, watching them drop from 80,000 feet to 50 feet in less than a second. But pilots looking at the same airspace often saw nothing, or saw something only intermittently. Infrared sensors sometimes captured the objects. Sometimes the same sensors showed empty air where radar insisted something was. This is not stealth. This is something else. As if the phenomenon is only visible when it chooses to be, or visible differently to different kinds of observers. And no visible propulsion ties it all together. Rockets work by Newton's third law. For every action, an equal and opposite reaction. You throw mass out the back, the reaction pushes you forward. The more mass you throw, the faster you throw it, the more you accelerate. All our aircraft work on some version of this principle. Propellers push air, jets push combustion gases, rotors push air downward. The phenomenon shows none of it. No exhaust plumes, no air displacement consistent with propellers or rotors. Objects hover with no visible means of support, then accelerate away, leaving no trail, no wake, no evidence of mass being ejected. If Newton's third law holds for these objects, and we have no reason to think it doesn't, then either they are ejecting something we cannot detect, or they are not moving themselves through space in the ordinary sense. Which brings us to a different possibility entirely. Consider what we've assembled. Objects that accelerate without apparent application of sustained force. Objects that move hypersonically without heat or shock. Objects that transition between media without adaptation. And that are selectively visible, moving without visible propulsion. Any one of these, if genuine, would require revising our understanding of physics, not just adding new knowledge, revising fundamental assumptions. The way relativity revised Newtonian mechanics, the way quantum mechanics revised everything. But all five observables together, all five together suggest not a gap in our physics, but a different physics. A physics we do not possess. A physics that makes our physics look like what Newtonian mechanics looks like from the perspective of general relativity. True enough in a limited domain, but fundamentally incomplete. Provincial. The word provincial is deliberate. General relativity doesn't say Newton was wrong. It says Newton was describing a special case, the low velocity, low gravity limit of a more general truth. Einstein's physics contains Newton's physics, but exceeds it. If the phenomenon is real, our physics may be provincial in the same way. True in our domain, but false as a general description of what is possible. Human perception is fallible. Instruments malfunction. Analyses contain errors. Any given case might have an explanation we haven't found. But the pattern is too consistent to dismiss in aggregate. Military pilots, trained observers with careers on the line who have every incentive not to report things that make them look crazy, keep reporting the same features. Multiple sensor systems, radar, infrared, and visual keep recording consistent impossible characteristics. The cases come from different countries, different decades, and different military and civilian contexts. At some point, the hypothesis that this is all misperception becomes less parsimonious than the hypothesis that something real is being perceived. Something that our physics does not accommodate. The question then is what physics would accommodate it. Here's a different way to think about the Five Observables. What if these objects aren't moving through space in the way we normally mean? Ordinary motion involves an object changing its position within a fixed spatial background. You walk from the kitchen to the living room. Your body moves through a space that stays put. A plane flies from New York to Los Angeles. The plane moves. The geography remains. But general relativity taught us that space is not fixed. Space-time curves in the presence of mass and energy. The curvature is gravity. Planets do not orbit the Sun because of an invisible force tugging them. They are following straight lines through curved space-time. The Sun's mass bends the geometry, and the planets roll along the contours. If space can curve, can it be made to curve artificially? Can the geometry be engineered? Theoretically, yes. In 1994, the Mexican physicist Miguel Alcubierre published a paper that would become famous in both physics circles and science fiction fandom. He proposed a solution to Einstein's field equations that allowed for effective faster-than-light travel without violating relativity's prohibition on superluminal motion. The idea, in simplified form, instead of an object moving through space, the space itself moves. Contract space in front of the object and expand it behind. And the object rides the wave of space-time distortion like a surfboard on water. Locally, the object isn't moving faster than light. It may even be stationary within its bubble of normal space-time. But the bubble itself is being carried along by the warp in the larger geometry. This is called the Alcubierre drive, or more generally, a warp drive. It's the physics behind Star Trek's fictional technology. Though Alcubierre wasn't inspired by the show, he was exploring what the equations allowed. The catch: the Alcubierre metric requires exotic matter with negative energy density to work. Specifically, it needs enormous amounts of it. Early calculations suggested more negative energy than exists in the observable universe. Subsequent refinements brought the number down, but it remains technologically inaccessible by any means we know. Also, we don't know if negative energy density at the required scales is even possible. The Casimir effect demonstrates tiny quantities of negative energy in laboratory conditions, but the gap between that and what a warp drive would require is astronomical. So the Alcubierre drive remains theoretical. A mathematical solution to Einstein's equations, not a blueprint for construction. But here's what's interesting. If you had a warp drive, what would it look like to observers? Think about it. An object in a warp bubble isn't moving through air. The local space it occupies is being translated through the larger geometry. From inside the bubble, you are stationary. From outside, you appear to move without any apparent mechanism. No exhaust, because you're not pushing off anything. No sonic boom, because you're not moving through the air. The air is moving with you. No heat from friction, because you're not rubbing against anything. Instantaneous acceleration, because the movement is a function of space-time geometry, not applied force on a mass. An object in a warp bubble would exhibit many of the five observables. And I'm not saying the phenomenon uses Alcubierre geometry. The Alcubierre metric is a solution within general relativity. There may be other approaches to metric engineering that we don't yet have the physics to describe. The phenomenon might be operating on principles we can't currently even formulate. But the general category is suggestive. Call it spacetime engineering. Instead of building vehicles that push through space, you build vehicles that manipulate space itself. The space does the moving. The vehicle is carried along. If you can engineer space-time, the five observables aren't impossible. They are expected. Metric in this context refers to the mathematical description of space-time geometry, how distances and durations relate to each other across the four-dimensional manifold. General relativity is essentially the study of how the metric is shaped by the distribution of mass and energy. Metric engineering is the hypothetical capacity to artificially control the metric, to sculpt space-time the way we currently sculpt matter. Consider what this would mean. The light speed barrier, currently absolute, becomes negotiable, not by moving faster than light, but by shortening the distance that light has to travel. Distance itself becomes adjustable. Inertia, currently the fundamental constraint on acceleration, becomes a local phenomenon. If you are not moving through space but reshaping space around you, the normal inertial effects don't apply. G-forces don't crush you because you're not accelerating in the relevant sense. Gravity, currently the one force we can't shield against, becomes manipulable. Gravity is curvature, and if you can control curvature, you control gravity. Though it gets murky when considering energy requirements. We don't know what energy is required for metric engineering because we don't have a theory that describes it operationally. Current calculations for Alcubierre-type geometries suggest exotic energy requirements that may be impossible. But current calculations are based on current theory, which is admittedly incomplete. General relativity and quantum mechanics don't fit together. We know something is missing. And what's missing might include possibilities we can't currently compute. What kind of civilization treats spacetime as a medium rather than a backdrop? We might call them post-Einsteinian, in the same sense that we might call a civilization that manipulates atoms but doesn't know about subatomic particles pre-quantum. They would have achieved mastery over a domain of reality that we can barely describe mathematically. Gravity for them would be a tool. Distance would be adjustable, and perhaps time as well. Though temporal metric engineering opens conceptual cans of worms that even physicists prefer not to handle. Such a civilization would be, from our perspective, nearly omnipotent in the physical domain. What we call the laws of physics would be to them the default settings, adjustable and overridable, even hackable. Here, the Gnostic parallels become almost too precise. The Demiurge builds the cosmos according to certain laws. The Archons administer those laws. The prison operates because its walls are solid, its constraints are real, its physics consistent. But the walls are made of spacetime, and spacetime, we now know, is not fundamental. It's emergent, arising from something deeper, more information-like, more malleable. If you can manipulate the substrate from which space-time emerges, you can modify the prison from the inside. You can walk through walls that most prisoners don't even recognize as walls. And the phenomenon may be demonstrating precisely this. If it possesses metric engineering capability, or any technology that achieves similar effects through different principles, a question arises that has nothing to do with physics and everything to do with consequences. What happens when this becomes public knowledge? Not just acknowledged, but unexplained, the way UAP are now. I mean public knowledge in the sense of the technology exists, here are its principles, and here is how it can be replicated. This is the revelation problem. Not the problem of determining whether the phenomenon is real. We are provisionally past that. The problem of what follows from its reality. All our technology rests on energy. This is so fundamental that we forget to notice it. Every machine, every process, every human activity requires energy input. Our civilization runs on the transformation of energy from less useful forms to more useful forms, or more precisely, on the extraction of work from energy gradients. Currently, we extract that energy primarily from fossil fuels, concentrated sunlight from millions of years ago, stored in hydrocarbons. Secondarily, from nuclear fission, hydroelectric power, solar and wind. In each case, we are tapping a source, managing a flow, paying a cost. Propellantless propulsion changes everything. If objects can accelerate without reaction mass, the energy has to come from somewhere. But it doesn't come from fuel in the conventional sense. If objects can hover indefinitely without expending energy to counter gravity, something is radically different about how energy is being used or generated or tapped. Some speculative proposals involve zero-point energy, the quantum vacuum fluctuations that pervade all of space. Others involve high energy density systems that we can't currently imagine. Others suggest that metric engineering might access energy from the geometry of space-time itself. Whatever the source, the implications cascade. If you can extract usable energy from the vacuum, fossil fuels become obsolete. Not gradually, through a generations-long transition. Immediately obsolete, like whale oil after petroleum. If you can generate effectively unlimited energy, the entire economics of scarcity transforms. Manufacturing, transportation, agriculture, desalination, and climate control. Every sector that is currently constrained by energy cost is suddenly unconstrained. If you can manipulate gravity, transportation becomes unrecognizable. Aircraft that don't need wings, spacecraft that don't need rockets, structures that don't need foundations in the conventional sense. And this is not utopia. Unlimited energy doesn't solve human stupidity, cruelty, or political dysfunction. It might amplify them. A species with our current psychological profile and unlimited energy capacity is a species capable of destruction on a scale that makes nuclear weapons look provincial. But it is transformation. The deepest transformation since the discovery of fire. Fire was our first technology of energy extraction, accessing stored chemical energy through combustion. Every technology since has been a refinement on that basic move. Metric engineering, if it's real, is a different move entirely. Not a better way to do what we've always done. A different game. A different tech tree. And who controls this matters a lot. And here's the uncomfortable implication. If the phenomenon is what it appears to be, someone already controls it. Or multiple someones. The technology exists. It is being demonstrated. Whoever is demonstrating it, alien, ultra-terrestrial, human breakaway, interdimensional, or something we have no category for, has already crossed the threshold that we are approaching. We are not first. Now, energy is the practical concern, but there's a deeper one. If others have solved physics, if there are intelligences operating with technology that treats space-time as malleable, what else have they solved? Consider the implications carefully. Have they solved death? If you can manipulate space-time geometry, you can, in principle, manipulate time. Not just travel through it, slow it, stop it, perhaps reverse it locally. A civilization with metric engineering capability might have access to temporal modifications that make biological death relevant. Back up the pattern of a mind. Restore it after damage. Loop a consciousness through a region of spacetime where entropy runs differently. I know, this sounds like fantasy, but it may not be. The physics that would be required for the Five Observables already enters territory where our intuitions about what's possible should be suspended. Have they solved scarcity? If energy is unlimited, and if matter can be manipulated at the atomic level, for example by nanoscale assembly, transmutation, or more exotic processes, then material scarcity vanishes. You can build anything if you have the energy, the information, and the time. A civilization with access to these capabilities has moved beyond economics as we understand it. Have they solved consciousness? This one, I agree, is speculative even by the standards of this discussion. But if the phenomenon involves non-human intelligences, whether biological, synthetic, or something else entirely, then those intelligences have conscious experience. They could have solved the problem of instantiating consciousness in some substrate. They may understand what consciousness is in ways we don't. And if consciousness is, as some theories suggest, fundamental, if it's not produced by matter, but is the ground from which matter emerges, then a civilization that understands consciousness deeply might have access to levels of reality that metric engineering doesn't touch. And this is where the Gnostic framework reasserts itself. The Demiurge built the material prison. The Archons, as I said, administer it. But the pneuma, the spark, the conscious essence, doesn't belong to the Demiurge's creation. It comes from the Pleroma. It is, in some sense, prior to space-time. A civilization that has mastered metric engineering has, in Gnostic terms, learned to manipulate the Demiurge's materials. Impressive, transformative, but not ultimate. The ultimate question, the Gnostic question, is whether they have also learned what the spark is. Whether they have achieved gnosis. Whether their mastery of matter and space-time has led them through to the other side, or whether they are simply the most sophisticated prisoners. We don't know. The phenomenon doesn't tell us. But the question matters. Because if the phenomenon represents beings that have metric engineering but not gnosis, beings that have power but not wisdom, then they may be, in effect, technological archons, administrators of a higher level of the prison, guardians capable of more impressive feats, but guardians nonetheless. On the other hand, if the phenomenon represents beings that have passed through the material to the spiritual, if they have solved consciousness as well as physics, then they may be something like the Gnostic messengers, the Aeons who descend with liberating knowledge, the light that enters the darkness, or both, or neither. This is the cosmological implication. The phenomenon is not just a physics puzzle, it is an ontological puzzle. What kind of beings demonstrate these capabilities? What do they understand and what do they want? These are not questions physics can answer. Physics can tell us what they are doing, or at least constrain our guesses about what they are doing. It cannot tell us why or who. For that, we need a different kind of inquiry.